Okay, then let's continue with another rushing session with a new panel. The subject of this panel is session sector integration. So we are going to explain what we mean by sector integration. I am very happy to host here two nice people, René SCHUTTE from GASUNIE and also one of the Hydrogen Europe organization, right? And Bertrand from McPhy. These are the two people we are with whom we are going to address this subject of sector integration. So we are going to start with some explanation of the concept, right? And I think that you brought one or two slides with you to explain about that.
Yes, that's correct.
Okay, René, can you please send the two slides?
I just want to explain what sector integration is about and actually why hydrogen is a solution, or a key solution for the energy transition. I took a picture which is from the Netherlands, but I think it's common in other countries as well. This is the division between energy use in terms of electricity and in terms of molecules. And if you look at the electricity, it's far below the level of energy that is consumed with oil and gas. But moreover, it's about the flexibility, about having the energy at the time that you need it. And that function is now fulfilled by gas, by natural gas. And it's very difficult to fulfill that same task with electricity, so with the use of batteries, for instance. Electricity use is about 20%, the rest molecules is about 80%. So the energy transition cannot do only with electricity, with electrons, it also needs molecules. We did some study about it, also in terms of cost. And what you see is if you have an all-electric system, it's basically not affordable, and you need a lot of renewable energy sources, which have actually at this moment in time little location, at least in Europe, to be situated. Then going to the next slide to show what's happening with the electricity grid. You see the electricity grid in the Netherlands on a certain day in the year, where we already had electrolyzers converting electricity into hydrogen. And on the left picture you see that the electrolyzers are placed near the production of wind or solar energy or at import terminals. And on the right you see that the electrolyzers are placed at the demand. This picture shows immediately that there's a high overload of the electricity grid, which has already been expanded, in this case more than twice. So if you try to use only electricity, that won't help. So the key solution is we need sector integration. We need to make sure that it's not a pillar on electricity, a pillar on methane, a pillar on hydrogen, a pillar on heat, but it needs to be a cooperation between the pillars, and for that you need sector integration.
So we need to change the vector.
Yes.
So starting from the wind and going to the gas.
Yes.
Basically, this is the power to gas concept.
Yes, actually, that's indeed the case, and it's of course because you can store gas much more easy and much more affordable than you can store electricity. So renewable energy sources are intermittent and variable, so that means that you don't always have the energy when you need it, and gas is the means to store it for the times that you can use it.
Can you give us an order of magnitude, understanding the numbers? What are we talking about here in terms of quantity of energy that we are considering in this sector integration? Do you have a few ideas about that for us to share?
If you look at hydrogen, we envisage that, let's say, and the numbers differ between the different studies, but the study that Hydrogen Europe did, the vision is that it will go up to 24% of use of hydrogen in the final energy use by 2050. So a quarter of all energy used is with hydrogen. And part of this is done by sector integration, part of it is of course direct to fulfill the feedstock requirements, to fulfill high temperature requirements. but a part is for the electricity grid to make sure that we have electricity at the times that we need it.
Okay, but in Northern Europe, of course, the renewable energy, wind, and mainly wind, I would say, is already very much deployed. So you already have this need for the storage for strategy?
You mean for the wind?
Something for the next
I think there's still plenty of room for renewable energy sources, but in the end you need to have import as well. You can't produce all the energy in Europe, I believe. You should produce it in areas where there's high wind load and high solar load, and it's predominantly in different areas. As to storage, storing of hydrogen, that can easily be done. There's sufficient space, at least in salt caverns, that are available or can be made available, and maybe in future even in former gas fields.
And are you backing this strategy with concrete projects, things to be deployed in the next couple of years?
Yes, in the Netherlands we are quite active with projects, at least as GASUNIE, but there are more parties, also partners of us, that are involved in projects, basically to start solve the chicken and egg story and start to produce supply in connection with demand. And the big question, of course, in this decade is the scaling up to the sufficient levels of hydrogen production, but also to the cost that is comparable to cost of alternative today.
So we have renewable production for electricity. We have gas networks where we can store some of that energy. We need to convert that between the two. To make this happen, we need some technology, right? Mainly electrolyzers, if I'm not wrong. Bertrand?
Absolutely. I think the learnings from the strategy presented by GASUNIE really make sense in terms of integrating energy, industry, and other sectors. And electrolysis is what we call the enabler. Enabler because that's a device that will bring you the flexibility on the one hand. It has to be also modular because the volumes are increasing. And of course, hitting high safety standard. We are very glad since 1 week now, we have announced a joint project with GASUNIE and Nourion and the financing of the FCHEU Europe to develop the first 20 megawatt platform. I think it will be one of the biggest in Europe and probably in the Netherlands.
Can you tell us more about that project?
Yes, absolutely. So the project aims at delivering green hydrogen based on wind park production for chemical production, which will be green methanol. Methanol is known as being used as a feedstock either for chemicals or for transportation. So in this chemical park, the key point was to catch up electricity at competitive price. So you need electrolyzers which are flexible and very fast response. So the aim of the project will exactly to show and implement the strategy explained by René, how to make competitive green hydrogen connected with industry, energy, and I believe one day there may be some storage of hydrogen as well.
So is the plan really to capture the off-peak market demand? Well, we call that surplus, but surplus is actually means nothing in terms of electricity, but you really mean that you are going to be a responsive consumer?
Yes, and for at least 2 good reasons. Of course, first, because that's a way to be competitive. You have 2 strategies. If you are connected directly to a wind park, you need to have a fast response system to exactly follow the load charge of the wind park or the PV park. The second strategy, which is indeed implemented in Nourion in this chemical part, is that they work with market capacity. So you need to buy slots, 5 minutes, 15 minutes of electricity. They have a nice control command and market energy marketplace, where they purchase on spot and with PPA the right energy mix. So your electrolyzer has to be fast response to answer to this competitive electricity price market.
So it's on the spot Apex. You actually directly buy hours on the spot Apex.
Exactly. So there will be a combination of both on this project, spot Apex, and sometimes connected to directly to the wind park.
So there should be a trader somewhere in the consortium, no?
Nourion is making the trader. They have the marketplace themselves inside. I visited, and you see the operators making their strategy on 3 days ahead, and they buy Apex, and they will run the electrolyzer based on that. Absolutely.
Okay, so beyond this very interesting project, it's Groningen, I think, no?
Yes, it's Groningen, yes.
It's Groningen in the Netherlands. Now I would like you to take the other hat, the Hydrogen Europe hat, and that you tell us a little bit how you foresee the extension of this kind of project and concept to other markets. Is this something that for which there is a roadmap or something that is being thought in the organization?
Yes, of course it's thought about. There has been made a Hydrogen Europe roadmap to make the next steps in developing and the hydrogen market and hydrogen economy in Europe. But it's of course required to, with a lot of people, with a lot of industry to help out, but also with the help of governments, because governments need to facilitate and help paving the pathway to do that. I think strategy is hydrogen can help solving the gap towards the 2-degree scenario, can take half of the problem that's still outstanding. In the different sectors that we have, which is industry, which is feedstock, which is electricity-free or CO2-free electricity production, but also in households which still have a lot of CO2 emission. But again, that needs to be done by projects, and the projects need to start on a smaller scale, and we need to cooperate to scale up. So it won't start as one Europe project, if you like, but it will start in regions. I think what's happening at this moment in time, which is facilitated by Hydrogen Europe, is the development of the IPCEI process. The IPCEI process is, let's say, a procedure regulation by European Union, which allows for state aid above 60%. If you want to step up and solve market failure, because actually we're looking at the kind of market failure for hydrogen. Hydrogen Europe now is facilitating that process, bringing together people from all over Europe to make sure that we have projects and we can connect the projects to each other, because the projects are all regional or local, if you like. We need to connect the projects together and help governments to decide to start with the IPCEI process and start in the end with investing in the new value chain.
Can one of you tell us what is the global ambition in terms of numbers? Where do we want to go with that? Bertrand, I think you gave me a few numbers.
Yes, the numbers are big if you make a strategic forecast. In Europe now we are speaking at 2030 about 80 gigawatts. Now, what does it mean if we look at the reality of our system? It means essentially two things. First, it's like a chicken and egg. We had known that in the road transport for hydrogen, but it's the same for renewable. The more we have renewable growing up, and I speak about the North Sea and offshore parks, 14 gigawatt, I think, in Netherlands, and more than 60 between Germany and Denmark, you will need high capacity of storage to manage the intermittency. So the numbers that are put ahead of decarbonizing industry and helping renewable to find their place on the grid in Europe are roughly 40 gigawatt on Europe and 20 plus 20 on international hub, who could be on the Mediterranean, on East Europe. Which means that to do that, which is not crazy with respect to the demand of hydrogen in the coming years, you need to have integrated supply chain, and I think the example shared by René makes a lot of sense, because Netherlands pushed this integration of supply chain from offshore to industry and gas grid. So supply chain integration is key. And the second, it will be manufacturing, how we scale up to deliver 1 and then 4 gigawatt per year at European market to be at the numbers that will be in the future.
Yeah, because in terms of power, 40 gigawatt, it's a lot. How are we going to cope with that in terms of technology for electrolysis, for example?
So two points on that. One is electrolysis, and all the manufacturers are working on that. In McPhy, we have 300 megawatts per year capacity, but with all the players, what we are looking is to create a coalition. It could be through European project of interest, common interest. The second topic will be to absorb the hydrogen in the grid, and I think most of the gas grid players now are speaking about 5 to 10%. We made a calculation with GRT Gas, 10% of green hydrogen in the mix of France means 40 terawatt hour. That's roughly 9 gigawatt of electrolysis needed.
9 gigawatt for France only.
Exactly.
Yeah.
That's the order of magnitude. And I think 6 gigawatt or 5 gigawatt is the number forecasted in Netherlands, correct?
On the renewable energy, you mean? Or you mean on the electrolysis?
Electrolysis.
Electrolysis. I think the plans are now for 3 to 4 gigawatts in 2030, but it will scale up to the plans we have for the North Sea Wind Power Hub, for instance, which are artificial isle in sea. That should in the end connect 180 gigawatts of wind power on several artificial isles in the sea, and then bring the hydrogen to shore. And that should be there somewhere in 2050. It's not all Dutch wind. It's wind from Denmark, Netherlands, UK. Hopefully they will still join, and also Germany.
So, to conclude, if all of this goes well, there is a bright future for electrolyzers manufacturers. And second, we will have a lot of green hydrogen available on the market to supply the different types of usages that we can imagine.
Yes, and I would say the benefit for Europe, companies and citizens, is really a win-win in terms of decarbonization. Why that? If we reach 35 or 40 euro per megawatt hour of electricity price offshore, which is already the current, I think, market price on the market, you can have with electrolyzer a price of electricity which be close to 3 euro per kilo in the future. At 3 euro per kilo, I believe transport for fuel cell will be very competitive and very happy. And then you can have steel plants who will maybe still have a premium respect to traditional hydrogen with SMR and carbon capture, but they may valorize their green or low carbon steel selling cars, which will have a premium, because I believe if you buy an electric or a hydrogen car, you would like your steel to be green steel, low carbon, and I'm sure there will be some customer happy to pay maybe 400 euro per kilo more on a car, but you have green steel made in Europe. So it's really the benefit of the full economy to make hydrogen, green hydrogen, competitive on the market.
Okay, so the target of 5 euro per kilogram at the end in the marketplace is something that is not totally inconceivable.
At the end, we need a lower price. I think we need to go to 1 to 2 euros per kilogram.
At cost.
At cost.
I'm talking
yes.
of market price.
Yes, market price depends on the market. If you look at the heating processes, for instance, there are different market prices over there than if you look at mobility, for instance. So it depends on the market where you are. But the market prices will come down. I think we should also not forget that we can use existing infrastructure with the energy transition, and it helps out as well because it can speed up. And don't forget the jobs we can create if we take on the lead in Europe and develop the industry and make sure that we have the technology, because it's not only for Europe, it will also be for countries further away.
Okay, thank you very much. We've done our time. It was very interesting. It's very interesting to know that in the foreseeable future, there is a plan to produce massively green hydrogen in Europe, and that's a good news. Thank you very much. Have a good day.
Thank you.
Very much.
Thanks.
Thank you. Thanks.